Hey, this is Katrina Datulio. So, to continue the discussion, let's move on to the limitations of financial models. Many companies tend to not consider social and organizational dimensions that may affect the true costs and benefits. The company's information systems investment decisions do not consider costs from organizational disruptions created by a new system, such as the cost to train end users, the impact that users' learning curves for a new system have on productivity, or the time managers need to spend overseeing a new system-related changes. Next is, what are the principal risk factors in information systems projects and how can they be managed? First is the dimensions of project risk. So in every project, there will always be risk. The number of risks is not always the same. It depends on several factors that may influence it. So the level of project risk is influenced by project size, the project structure, and the technology. So in project size, the larger or more complex the project, the greater the risk. So project risk increases with the size of the project because such projects are complex and difficult to control. This can affect the time and resources required to bring a project to completion. Some of the risks that could come along with it is that people will lose interest as projects may cover many months, your funding will dry up, your project will never end, and also the cost will increase. In project structure, structured, defined requirements run lower risk. Their requirements are clear and straightforward, so outputs and processes can be easily defined. Users know exactly what they want and what the system should do. There is almost no possibility of the users changing their minds, unlikely than those with relatively undefined and constantly changing requirements with outputs that cannot be fixed easily because they are subject to users changing ideas or with users who cannot agree on what they want. Lastly is the experience with technology. The project risk rises if the project team and the information system staff lack the required technical expertise. If the team is unfamiliar with the hardware, system software, application software, or database management system proposed for the project, it is highly likely that the project will experience technical problems or take more time to complete because of the need to master new skills. Second is change management and the concept of implementation. So in change management, it's the introduction or alteration of an information system. New information systems have powerful behavioral and organizational impact. First impact is the changes in the way that information is defined, accessed, and used to manage the organization's resources often lead to new distributions of authority and power. And this eternal organizational change breeds resistance and opposition that can lead to the demise of an otherwise good system. So, a very large percentage of information systems projects stumble because the process of organizational change surrounding system building was not properly addressed. That's why a successful system building requires careful change management. Now, the concept of implementation. So, to manage the organizational change surrounding the introduction of a new information system effectively, you must examine the process of implementation. Implementation refers to all organizational activities working toward the adoption, management, and routinization of an innovation, such as a new information system. In the implementation process, the systems analyst is a change agent. So the analyst not only develops technical solutions but also redefines the configurations, interactions, job activities, and power relationships of various organizational groups. The analyst is the catalyst for the entire change process and is responsible for ensuring that all parties involved accept the changes created by a new system. Also, the change agent communicates with users, mediates between competing interest groups, and ensures that the organizational adjustment to such changes is complete. Now, the role of end users. System implementation generally benefits from high level of user involvement. So, user participation in the design and operation of information systems has several positive results. First, system more likely to conform to requirements. If users are heavily involved in system design, they have more opportunities to mold the system according to their priorities and business requirements, and more opportunities to control the outcome. Second, users more likely to accept system. They are more likely to react positively to the completed system because they have been active participants in the change process. Now, the relationship between users and information systems specialists has traditionally been a problem area for information systems implementation efforts. Users and information systems specialists tend to have different backgrounds, interests, and priorities. These differences lead to divergent organizational loyalties, approaches to problem solving, and vocabularies. Information systems specialists, for example, often have a highly technical or machine orientation to problem solving. They look for elegant and sophisticated technical solutions in which hardware and software efficiency is optimized at the expense of ease of use or organizational effectiveness. Users prefer systems that are oriented towards solving business problems or facilitating organizational tasks. Often, the orientations of both groups are so at odds that they appear to speak in different tongues. These differences are illustrated in the table, which shows the typical concerns of end users and technical specialists regarding the development of a new information system. Next is the management support and commitment. If an information systems project has the backing and commitment of management at various levels, it ensures the following. With management backing, it affects positive perception by both users and technical staff. Both groups will believe that their participation in the development process will receive higher level attention and priority. Management backing ensures sufficient funding and resources and helps enforce required organizational changes. All the changes in work habits and procedures and any organizational realignments associated with the new system depend on management backing. If a manager considers a new system a priority, the system will more likely be treated that way by his or her subordinates. Next will be the change management challenges for business process reengineering, enterprise applications, and mergers and acquisitions. Given the challenges of innovation and implementation, it is not surprising to find a very high failure rate among enterprise application and business process reengineering projects. As a consequence of these inherent risk in project implementation, there are very high, up to 70% failure rates. So many enterprise application and reengineering projects have been undermined by poor implementation and change management practices that failed to address employees' concerns about change. These concerns including dealing with fear and anxiety throughout the organization, overcoming resistance by key managers, changing job functions, career paths, and recruitment practices. These employees' concerns about change have posed greater threats to engineering than the difficulties companies face visualizing and designing breakthrough changes to business processes. That's why all of the enterprise applications require tighter coordination among different functional groups as well as extensive business process change. Now, projects related to mergers and acquisitions have a similar failure rate. Mergers and acquisitions are deeply affected by the organizational characteristics of the merging companies as well as by their IT infrastructures. So merging of systems of two different companies usually requires considerable organizational change and complex systems projects to manage. So without this successful systems integration, the benefits anticipated from the merger cannot be realized. Or worse, the merged entity cannot execute its business processes effectively. Third is controlling risk factors. So various project management requirements, gathering, and planning methodologies have been developed for specific categories of implementation problems. Strategies have also been devised for ensuring that users play appropriate roles throughout the implementation period and for managing the organizational change process. Not all aspects of the implementation process can be easily controlled or planned. However, anticipating potential implementation problems and applying appropriate corrective strategies can increase the chance for system success. The first step in managing project risk involves identifying the nature and level of risk confronting the project. After, implementers can then handle each project with the tools and risk management approaches geared to its level of risk. First is in managing technical complexity. Projects with challenging and complex technology for users to master benefit from internal integration tools. Internal integration tools is a project management technique that ensures that the implementation team operates as a cohesive unit. Example of this is that project leaders need both heavy technical and administrative experience. They must be able to anticipate problems and develop smooth working relationships among a predominantly technical team. Team members should be highly experienced. The team should be under the leadership of a manager with a strong technical and project management background, and team meetings should take place frequently. Lastly, essential technical skills or expertise not available internally should be secured from outside the organization. Second is the formal planning and control tools. These tools are for documenting and monitoring projects that benefit highly structured projects. The two most commonly used methods for documenting project plans are Gantt charts and PERT charts. A Gantt chart lists project activities and their corresponding start and completion dates. The Gantt chart visually represents the timing and duration of different tasks in a development project as well as their human resource requirements. Although Gantt charts show when project activities begin and end, they don't depict task dependencies, how one task is affected if another is behind schedule, or how tasks should be ordered. So that is where PERT charts are useful. So PERT chart stands for Program Evaluation and Review Technique. It's a methodology developed by the U.S. Navy during the 1950s to manage the Polaris submarine missile program. So a PERT chart graphically depicts project tasks and their interrelationships. The PERT chart lists the specific activities that make up a project and the activities that must be completed before a specific activity can start. Both Gantt and PERT charts help managers identify bottlenecks and determine the impact that problems will have on project completion times. Here's an example of a Gantt chart used in a data administration project. In this figure, it shows the task, person days, and initials of each responsible person as well as the start and finish dates for each task. The resource summary provides a good manager with the total person days for each month and for each person working on the project to manage the project successfully. Next is a simplified PERT chart for creating a small website. It shows the ordering of project tasks and the relationship of a task with preceding and succeeding tasks. Third is increasing user involvement and overcoming user resistance. Projects with relatively little structure and many undefined requirements must involve users fully at all stages. So users must be mobilized to support one of many possible design options and to remain committed to a single design. External integration tools consist of ways to link the work of the implementation team to users at all organizational levels. For instance, users can become active members of the project team, take on leadership roles, and take charge of installation and training. But participation in implementation activities may not be enough to overcome the problem of user resistance to organizational change. Different users may be affected by the system in different ways, such as users may believe change is detrimental to own interests. If the use of a system is voluntary, users may choose to avoid it. But if use is mandatory, resistance will take the form of increased error rates, disruptions, turnover, and even sabotage. Therefore, the implementation strategy must not only encourage user participation and involvement, but it also must address the issue of counter-implementation. So counter-implementation is a deliberate strategy to thwart the implementation of an information system or an innovation in an organization. Now, here are the strategies to overcome user resistance: user participation, user education and training, management ethics and policies, and better incentives for users who cooperate. The new system can be made more user-friendly by improving the end-user interface, and users will be more cooperative if organizational problems are solved prior to introducing the new system. We have now designing for the organization. Because the purpose of a new system is to improve the organization's performance, information systems projects must explicitly address the ways in which the organization will change when the new system is installed. So transformations in job functions, organizational structure, power relationships, and the work environment should be carefully planned. Now, areas where users interface with the system require special attention with sensitivity to ergonomics issues. So ergonomics refers to the interaction of people and machines in the work environment. It considers the design of jobs, health issues, and the end-user interface of information systems. So systems analysis and design activities should include an organizational impact analysis that explains how a proposed system will affect organizational structure, attitudes, decision-making, and operation. Also, to integrate information systems successfully with the organization, thorough and fully documented organizational impact assessments must be given more attention in the development effort. Now, one way of addressing human and organizational issues is to incorporate socio-technical design practices into information system projects. In here, designers set forth separate sets of technical and social design solutions. The proposed technical solutions are compared with the proposed social solutions, so the solution that best meets both social and technical objectives is selected for the final design. And the resulting socio-technical design is expected to produce an information system that blends technical efficiency with sensitivity to organizational and human needs, leading to higher job satisfaction and productivity. Commercial software tools that automate many aspects of project management facilitate the project management process. The project management software typically features capabilities for defining and ordering tasks, assigning resources to tasks, establishing starting and ending dates to tasks, tracking progress, and facilitating modifications to tasks and resources. Microsoft Office Project 2010 has become the most widely used project management software today. It is PC-based, with capabilities for producing PERT and Gantt charts and for supporting critical path analysis, resource allocation, project tracking, and status reporting. Project also tracks the way changes in one aspect of a project affect others. So some of these tools are large sophisticated programs for managing very large projects. These high-end tools can manage very large numbers of tasks and activities and complex relationships. That will be all for my presentation. Thank you.